Large construction projects have become increasingly complex. Sophisticated design, very tight budgets and schedules, and multiple uses of projects require construction and design teams that work as partners to resolve issues. Durotech Construction and its design and subcontracting partners respond to these challenges by creating virtual models of buildings before the actual work is put into place. These virtual models are highly complex. They show every detail planned in a building. When the building opens, this virtual model will provide a digital record of all plans, specifications, warranty information, building operating instructions, and even replacement part order forms. This will give facility managers tools to improve operating costs. This 500,000 square foot project is on 92 acres. 54 different subcontracting firms with over 600 field employees are building it under Durotech's direction. Hundreds of other companies are supplying materials. 10 different design and consulting firms are working with the architect to create the plans for the building. Everything on the project must be complete by a specific date and at a guaranteed price. Costs cannot increase, and time is of the essence. To accomplish it all requires intense management coordination and teamwork. The virtual model of the building is assembled by the Durotech Virtual Design Coordinator from drawings by different members of the design and subcontracting teams. It is used before and during construction to identify problems before building components are built and found to be wrong. Conflicts between the design of different materials, incorrect sizes and dimensions which cannot change must all be identified, corrected, and made to work. Many times the schedule is so tight, this is done just days before the materials are put in place. Durotech coordinates problem resolutions at the construction site with Durotech project field staff, Durotech's virtual design coordinator, and key subcontractors. Joining them online and by phone are the architect and other members of the design team.
Do you want to look at anything else in the catwalk area? There was another small conflict on the other side of the door. So now it matches with the design. So we're talking about these diffusers here.
So we're trying to force those ductwork down to those column wraps and then into the think tank area. Both options, either to leave the frames where they are and maybe create that bump out condition that will accommodate the flex duct taking place above and down that roof, that interior roof condition, or just raising the bottom of those frames with a furrow condition that runs across on both sides. So I'll look into both options for us.
Right.
Through structural beams. Okay. Work.
Yeah,
We're just trying to get it over there.
Yes,
Okay.
cross. Yeah, because it needs to cross the support system
That's
there.
correct. And above that, that's where we have what seems to be glass.
So we're looking at this bracing hitting the ductwork, going inch inside. So my only concern was that they are continuous bridging and all of them are hitting the duct here.
Looks like the bracing holding the angle for the masonry above it. Everywhere we
Really?
have that low high, we've got that condition with all that angle. So you got a double back-to-back angle on the roof side. For the masonry. Actually, what
beam
you
here-
have, and then you got a back-to-back angle sitting on top.
Setting outside and up.
Yeah.
Yes, and that's the one which is connected. I think it's welded or connected to this bottom cord,
There
and
you
then.
go.
So you're going to make there's a steel bracing hitting the duct. Myrex should have all the opening sizes and locations. So yeah, this can be fixed easily.
Let me take a look at the room that we are in. Process. Can I get that room number, please? Okay, so we're tracking what I think I got from your model for us is 13 feet at one point, and I think where you're going down the corridor, that's at 12 feet elevation.
No, that's not 13 feet. That's 11 feet.
It's 11? Okay.
Yeah. And
That's 10.
yes, and this one right here at the junction, that's 11.
So this is where we kind of go back to some of the issues that I know we ran into in areas A, B, C, and D, or going down that corridor, which right now it's comfortably at 10, and to push it at maybe 9 feet, then you can see what my concern is now. That becomes a 9 feet shallow corridor that runs all the way down to the point of exit.
Is there
9-6.
any scope for you to widen up the ducts?
There's no way to widen it because we've got fire damper, all side by side right now. See all of them coming out? They're all fire dampers coming down. Down.
Well, yeah, there's more. There's some here, and then
There,
down the line,
there, yeah.
there,
And
then
then
there. Okay.
yeah, it's hard to see.
So the most I can do on my end is to take that proposal over to the designers and include Kirk on it and see if there's a decision that they'll be comfortable in making. But
Not even with a big change. No.
Not even a big change because there's so many ducts in there, there's no way to widen them out and make them narrow.
Because we also have a high-low condition where we have about 20 feet of brick that needs to be supported by the high side and not the low side, because the only extra steel that I'm seeing in the details that I've cut is just bottom flange bracing, and then bracing also the CMU wall to our beam so we can transfer the load. And then I
That's
see
what
a
those
few
tabs
brick
are,
angles.
is it's bracing the CMU wall to the beam right there.
Yes.
Yeah, so that way we can transfer. That way we can transfer our lateral load from the beams into the CMU.
I think a few areas in particular where we're trying to get a lot of ductwork out of the mezzanine and to serve other areas on the first floor. And there's just not enough room between the ceiling and all of that structure that you got going on. So
Do we know how much of this miscellaneous steel has already been installed?
No, he's in that area now. He'll be hanging
Uh,
more Thanksgiving.
Yeah, they're starting on Monday, I guess, in this area.
7, there's like 4 decks that are right next to each other coming out of the mezzanine. Where
And so we wouldn't be able to fit an angle.
Possibly, if there's enough room in between the vertical, the risers. So I don't know. Maybe there's a way to fit some of those braces in between.
Our typical detail has this back bracing angle, and the purpose of this angle is to keep the bottom flange from buckling. Let me check the CMU angle detail and see if it's possible in this case to eliminate a few rows of these angles. I think it could be possible.
how are we supporting those bleachers?
The bleachers?
Yeah.
So first off, the first portion of them are supported by the slab, and then the second half that's over that area is supported by CMU, load-bearing CMU, and then we have a two-way slab, or a one-way slab that spans from the exterior CMU out to the shorter interior CMU wall. So all of that that's actually a concrete and CMU supported system.
Okay.
And so it's above, I think that area is a mechanical area, correct? Or a storage of some sort?
Yeah, storage and laundry and stuff like that. Yeah. Slab, that is.
Uh-huh.
Okay.
Yeah, we can't have openings like that in the slab.
I'm looking at my issue for proposal set. It's there.
they all seem small. So like I said, if you guys could just send us a proposal, maybe through an RFI, I can study this a little bit further.
Yeah, yeah, for sure. I mean,
R5, send it over to us, and we will definitely be exploring all options for this going forward.
The RCP, it's 10.
This is because it's not needed.
Right, because it's not
And
now.
10 isn't enough.
Mine is, I forgot the
Yes,
So it has to be 12.
Okay.
this light fixture is right up the storm drain, and there is the curtain wall from ceiling to
And the head
floor.
elevation for that storefront is up there at 10 as well.
That's a 12.
12.
Well,
Yeah,
12.
that's shown 12 in the model.
That room needs to, the ceiling there should be 9, and then the glass as well needs to be.
Okay. So it's going to be a clarification as well?
Yes, sir?
All right.
10 foot should be fine.
You don't have to go to 9.
9 foot?
Yeah,
Okay.
because right now it's 12. So, you know, addition.
If we're bumping those projectors up 6 inches, then that puts up us a little bit over 9 feet on the projector, so I guess 10 foot would be.
Yeah,
would work
10
out
foot
better.
ceiling would be fine.
I'm pretty sure that they're not gonna want a light penetrating the ceiling like that.
Exactly.
Now, I just wanna know if that ceiling is 100% accurate representation, or if it's just architectural, just for, the model for looks. If that sloped area where the lights are penetrating is actually gonna be there, or if it's going to be, not be there and allow the lights to come into that area.
So to align the lights with these openings,
I mean,
and you're trying to figure out.
I just don't know where to put the lights. I put them where the contract drawing shows. But it just doesn't work out with this model.
I can definitely clear up the true design intent. It seems as if it's just more coordination we're going to have to do at a later stage just to figure out exactly what's happening at that location. Yeah, I'll go ahead and definitely take a further look at exactly what the design intent is and then track it back through on the lighting plan. My only concern, I was looking at it seems as if I don't have the submittal for the RC, the roof, the ceiling feature there, so I'm not sure exactly what it is, but
Change these to support to align with duct conflict.
so this is a good example of where we have coordination between the two disciplines at a point where we thought, we just take the time to revisit and just have both teams work together, because at one point it was coming off as if it was impossible to get it done, and here we are with a solution that makes a lot of sense. So I appreciate the parties that were able to get together and get this done.
All right, thank you.
Unique use of virtual tools by Durotech include recording existing conditions with laser scans and mapping tools, using virtual models with field foremen and laborers to explain construction details as work is in progress for better quality, and last planner lean efficiency. The ability to access the virtual model from anywhere on the job site with any handheld device, and the use of 6D as-built models. Durotech delivers to owners proactive solutions by working in partnership with design and subcontracting teams. Taking virtual design techniques to a higher level to produce superior outcomes is just one tool used by Durotech and its design and subcontracting partners to better protect owner interests.